Hi everyone, this is your video for Tuesday, February 21st. This is on simple and compound events and probability. When it comes to determining if events in a question are simple or compound, you have to read for the specifics of a question in order to determine if you're dealing with simple or compound events. Essentially, and I've said this before in class, you need to determine the main idea of the question in order to figure out what you're exactly supposed to do. In a simple event, there's only one outcome that happens. Typically, simple events are synonymous with independent events. Compound events are typically dependent events because one variable influences the other. Here's an example of what I'm trying to talk about. My dog, Sonora, is a spoiled puppy. Each night after her scoop of food, she cries incessantly, but this time for a biscuit. We call it doggy dessert. Is Sonora begging for a dessert simple or a compound event? This is, of course, a simple event. The biscuit doesn't depend on the scoop of food that she received. These are also independent events. Look at this spinner that I've drawn that is divided into orange, purple, gray, and red. If I spin this spinner 3 separate times, what is the chance of the spinner landing on purple? Well, it's 1/4 because each section is broken up into fourths. But what about if you spin the spinner 3 separate times? Then the chances look like this. 1/4 times 1/4 times 1/4. But does it really change anything? In other words, do the first 2 spins and what you land on during those first 2 spins affect the third? The answer is no. Here's another example, except this time we're talking about a compound event. In the Pick 3 game of the North Carolina Lottery, you can choose 3 separate numbers, 0 through 9. Numbers may repeat. What is the chance of choosing 1, 1, 7? The answer is 1 out of 1,000 because there are 1,000 potential combinations. Here's another example. How many combinations exist with number combination of 5, 6, 7, and 8? There are 24. This tree diagram illustrates this. As you can see, we're looking at 5. It goes then to 6, 7, and 8, and then off of 6 you've got 7 and 8 as a choice, 6 and 8 as a choice, 6 and 7 as a choice. This gives you 6 total combinations starting with each number. And then as I extend this tree diagram out, you get a total of 24 total possibilities. Now answer these questions. Make sure that you show your work and come prepared Tuesday morning in class to answer these questions. Here's question number 1. Here's question number 2. Here's question number 3. And finally, question number 4. Thank you.